All right, quarter 3, week 6, day 3. We're going to solve a multiplication problem and a division problem. So let's do the multiplication problem first. All right, so since this just has one number, I'm going to put that one down below. So I'm going to have 4.57 times 0.08. All right, so that's going to make it that I only have to do this one time through. So we have 7 times 8, which is 56, right? So we'll put a 5 here, put a 6 down here. 8 times 5 is 40, plus 5 is 45. 8 times 4 is 32, plus 6 is 36, or plus 4 is 36. My goodness, my brain. Here we go. All right, so 8 times 4 is 32, plus 4 is 36, and that's all we have to do. At this point, we can just put a bunch of zeros down for the next one. Like we can put x here, and so 0 times each one is that, and then we put an x, and then 0 times 7, 0 times 5, 0 times 4. Okay, but that would be kind of unnecessary, but we did it anyway, I guess, just to show you that we could. And so the answer is 6, 5, 6, 3, right? And so now we just have to come up here and look how many numbers are to the right of a decimal point. Well, there's 1, 2, 3, 4 numbers to the right of the decimal. So we're going to move the decimal over 4 places. So the answer to the top one is 0.3656. Or if you want to, you could put a 0 in front of that. 0.3656. So that's the answer to this multiplication problem. All right, so now we're going to solve for this division problem here. Okay, as you can see, we have a decimal in the divisor. We wanted to get rid of it. So what did I do? I moved it over 1 place to the right. And now that's 31. And then I had to move this decimal over so it became 1931.3. So basically 1931.3. And I added some zeros just in case we have to go past the number. All right, so how many times does 31 go into 1? It can't. How many times does 31 go into 19? It can't do that either. How many times can 31 go into 193? I'm going to guesstimate that it's going to be about 6. So let's see if 6 works. 6 times 1 is 6. 6 times 3 is 18. All right, and then we're going to subtract that. Can't take 6 away from 3, so we're going to have to borrow. So we have 13 minus 6, and that's going to give us 7. Now we're going to bring down the 1. How many times does 31 go into 71? Well, 31 times 2 is 62. 31 times 3 is going to be in the 90s. So let's just say 2. 2 times 1 is 2. 2 times 3 is 6. Okay, borrowing from the 7, make it a 6. This becomes 11. 11 minus 2 is obviously 9. We have 9. Bring down the 3. 93. So how many times does 31 go into 93? Well, I can already see that this is going to work out very well. 3 times. 3 times 1 is 3. 3 times 3 is 9. All right, and we end up with no remainders. Okay, so with that being the case, we don't really need these zeros, and we just bring up the decimal. So the answer to this is 62.3. All right, that's all we have to do for those two. Okay, a soccer player scores 3 goals in 2 games. So 3 goals in 2 games. If we say that that's going to be the ratio all the time, it says how many goals are they expected to score in 9 games? Well, if we want to get 1 game, okay, make a unit rate, that's 2 divided by 2 is 1. 3, or half of 3, is 1.5 goals. So we can do 1.5 goals per game. Okay, or we can double the 2 and make it 4 games. you would expect there to be 9 goals, right? Because 2 times 2 is 4. 6. 3 times 2 is 6. Trying to go a little faster than I should. All right, so it says how many in 9 games? So in 9 games, that would be, we can just do 1 times 9 to get that, or then we can do 1.5 times 9. Okay, so if we do that, so we just do 1.5 times 9. 9 times 5 is 45. 9 times 1 is 9, plus 4 more is 13. We're going to bring over the decimal 1 place, so the answer would be 13.5 goals. That's one way we could have done it, or we could have actually taken the 2 and said, well, 2 times 3 is 6. 3 times 3 would be 9. So in 6 games, he'd get 9 goals. And then you could add another 3 games possibly, right, if we did that. So we can kind of scale up and down. But regardless, no matter how you approach it, you're going to end up with, in 9 games, there's going to be 13.5 or 13.5 goals. And that's your answer. Write an expression that represents the quotient of 24 and 3. All right, quotient means what type of math? Is that adding, subtracting, multiplying, or dividing? If you're finding the quotient, you are dividing. So the quotient of 24 and 3. So we're going to do that first. 24 divided by 3. And then what does it say to do here? Plus x. So we would just add x. So if we were to write an expression for this, I think this is what it would look like. You can even put a parentheses around there and make it 24 divided by 3. Clearly needs to be done first. Okay, but even if you didn't put that, order of operations would have you do that first anyway. So either way, 24 divided by 3 plus x. The most Gabriel has ever earned delivering newspapers is $43 in one day. So that's the most he's ever earned. Write an inequality, I kind of figured they would ask this, showing the amount Gabriel earns delivering newspaper. All right, so we're going to make x the unknown, okay, and 43 is the number that we know is the most, I guess, so he must have made exactly $43, okay, on some day. Since he's made $43, I'm going to put the little equal to sign there. And then I know that it's the most he's ever earned. So has he ever earned $44? No. Has he possibly earned $42, $41, $40, or maybe even just $5? Yeah, so he's earned less than 43. So x is going to be less than or equal to 43. So that's our inequality. X is less than or equal to 43. That's how much Gabriel earns each day delivering newspapers. Find the rule and solve for n. All right, so once again, whatever x is, there's a rule that it's going to have to follow, and it's going to become whatever the number is over here in the y column. It's called an input-output table. I think I can see it already. So if you don't, pause it and figure it out. Otherwise, I'm going to say it right now. 4 times 3 is 12. 6 times 3 is 18. 7 times 3 is 21. All right. So we know that whatever x is, you're going to multiply by 3. So y equals whatever n is times 3. So it's going to do 3x. So 3 times x equals y. All right, so what is n? So what number times 3 is going to give you 27? That is 9. 9 times 3 is 27. So n equals 9. Okay, we're going to find the volume. All right, so we know that volume is length times width times height. It's not surface area, it's volume. All right, and then down here I went ahead and wrote it already, and I already went ahead and changed them into improper fractions. Okay, remember you do 16 times 4. So 16 times 4 is 64, plus 3 more is 67. That became the numerator. 3 just becomes 3 over 1. 4 times 5 is 20, plus 2 more is 22. So there we have it. So now we're going to have to multiply across the top. So we're going to have 67 times 3 is 201 times 22. And that gives you 4,422. And then down here, the denominator is just 4 times 1 times 5. It's just 4 times 5, which is 20. Right? So, and we know that we can reduce this, okay, because we know that we can do half of 20 because they're both even. So it's going to end up being, well, half of 4 is going to be 2, 2, 1, 1 over 10. Right? So then, how many times will 10 go into 2,211? So that's going to be obviously 221. Yeah. So it's going to go into it 221 times. So if you do 221 times 10, you're going to end up with 2,210. So if we used up 2,210 out of 2,211, there's going to be 1 left over, right? So it's going to be 1 over 10. So let me just rewrite this over here so it's a little easier to see. Our answer is going to end up being 221 and 1/10. And since it's volume, inches cubed. All right, there's our answer. Danny has a triangular pyramid. Okay, so here's a triangular pyramid. All the triangles are congruent. What is the surface area? So basically, if this is a net, so if we folded it up, okay, it would end up being a triangular pyramid. And the critical part is they're telling us that all of the triangles are congruent. Congruent means they are all equal. If you see the word congruent in math, it means equal. All right, so let's look for the area of this one, and then we'll find the other ones real easy. So we have a base times height. The base is 5. The height is 6. 5 times 6 is 30. So that triangle is 30, right? No, not quite. Remember, that's going to be kind of the area of a rectangular or a parallelogram. Okay, but we don't want that. So 6 times 5 is 30, but half of that is 15. So if this one is 15, we know that all the rest of them, because of this word right here, are 15. Okay, so all you have to do is 15 times 4. Well, 15 times 2 is 30. So 15 times 4 is going to be 60. So it's going to be 60 inches, and since it's surface area, not volume, 60 inches squared. All right, so that would be your answer for that one. All right, so what statistical question could the data below answer? All right, well, what if we said, what is the population of Cartersville? Is that statistical? No, because it has one answer. What is the population of Cartersville? Just one answer. You can say that for each one of these little towns or cities or whatever they are. So that's not a statistical question. But what if they were asking something like, what was the population of the town you lived in when you were born? Okay, so when you asked several people that, so if you asked everybody in Cartersville what the population of Cartersville is, you're going to get one answer, right? That's not statistical. But if you asked everybody in Cartersville what was the name of the town, or what was the population of the town that you lived in when you were born, did everybody basically grow up in Cartersville, or did some people probably move in from somewhere else? Right, so someone probably moved in, so you're going to have a variety of answers, and maybe these are some of the other locations. All right, so see if you can think of another statistical question that might be what this data is for. So it could be anything, but as long as you ask a group of people, not just one, and you're going to get multiple different answers of different cities in which something happened. All right, so that's going to be important to know what a statistical question is.